Greetings and welcome to my new calculus channel. My name is John Gabriel, and today I'm going to be talking about the final two definitions of the most important book of the elements, book 5, and they are namely definition 17 and 18. So let's begin. Now, Heath obviously didn't understand these definitions very well. And he wasn't the only one. For example, someone like David Joyce has something really erroneous here, which I'll come back to in a moment. David Joyce also has his own site on Euclid's Elements, which is really just a copy of the original translation by Heath into a format that looks more aesthetically pleasing, but doesn't really have too much value above the original translation of Heath. So coming back to this, so what does ex-aequali mean? So ex-aequali is a Latin expression. Ex means from, and aequali means equal. So it really means from equal. Okay. So he said that these are taken in the same, or these are in the same ratio, taken 2 by 2. They don't have to be taken 2 by 2. They can be taken 3 by 3 or 4 by 4. It doesn't really matter how you take them. That's because Heath didn't really understand this definition. Okay, and I'll explain it to you in a moment. So it doesn't have to be 2 by 2, but you need at least to be able to get to a deeper understanding of this, you need at least 3 magnitudes in each of the ratios. Okay, and they have to be in proportion, by the way. There's nothing about equality there. They have to be in proportion. And of course, the word equality doesn't appear anywhere in these definitions. Okay, so equality has nothing to do with proportion. So let me state it this way. You need proportion for equality, but you don't need equality for proportion. Okay, so remember that. It doesn't go both ways. Now, for example, you can say 2/3 is equal to 4, is in proportion to 4/6. Okay, and in algebra, 2/3 is equal to 4/6, but not in geometry, because in geometry here there is no number yet. We're talking about magnitudes, which can be lengths, areas, volumes, etc. There are no numbers yet. We only get to numbers in book 7. Okay, so what does it say? So Heath thinks that it says, in other words, if P, Q, and R are the first set of magnitudes, in other words, the ratio P, Q, R, and the second ratio is STU, then the ratio via equality, it says, it's not via equality, it's via proportion, by the way. This is via proportion. It says that P and R is in proportion to S and U. And of course, even more than that, we can say that Q and R is in proportion to T and U. Okay, and we can also, any one of these combinations will do, right? We can say R over P is in proportion to U over S. So these ratios must be in proportion. Now, hilariously, poor David Joyce, who doesn't really know what he's doing anyway, thinks that this very same thing in definition 18, which we'll get to in a moment, perturb proportion, means this. He thinks it means this, where you've got this ratio here of 3 magnitudes in proportion to this one. It cannot be in proportion to this one here, because this line here would mean it's no longer in proportion. Okay, so it's kind of funny that he says then a perturbed proportion holds as shown here. No, that's not what is meant as a perturbed proportion. Moreover, if these poor ignorant mainstream academics had tried to actually get an example of such a proportion, they would have understood that this is entirely wrong. So I'll give you an example in a moment and show you what exactly is a perturbed proportion. But this is the correct definition of definition 17. A ratio ex aequali arises when there being 2 ratios with an equal number of magnitudes. They don't have to be 3. as long as they have 2 or greater, then any two magnitudes from either ratio, but in the same positions, very, very important, in the same positions, okay, the relative position must be the same, will be proportionate to each other. That's why you can't have nonsense like this. You can't have m being this long and h being this short, okay? They're totally out of proportion, right? So as you can see, this this particular ratio here in green is not in proportion to this ratio here, okay? Because if you had to, for example, add up all these lengths and divide it by k, and add up all these lengths and divide it by n, they would be totally out of proportion. Okay, so let's stop flagellating David Joyce. He is, after all, just another mainstream moron. Okay, and by the way, what you find on Wikipedia is also wrong. It says when there have been several magnitudes and another set to them in multitude, and they're taken 2 and 2. They don't have to be taken 2 and 2. They can be taken 3 and 3, as I said, or 4 and 4, etc. But anyway, coming back to this, so that's what definition 17 says. And let me give you an example. So what it says is if you take 7 plus 3 and divide it by 12, right, which is the total of this, and 14 plus 6, it must be, 14 plus 6 corresponds to 7 plus 3, right, divided by the total of this, then these two ratios are in proportion. They must be in proportion, because if they're not in proportion, it's no longer referring to the definition, okay, it's invalid. So in fact, the definition also suggests, as I said earlier, that more than 2 magnitudes can be taken from each ratio as long as relative positions are preserved. Okay, so again, you don't only have to say 7 plus 3, you could say 2 plus 7 plus 3 over 12 is in proportion to 4 plus 14 plus 6 to 24. 1 is definitely in proportion to 1, okay, because this evaluates to 1, and so does this. Now, definition 18. What does definition 18 say? So definition 18 talks about what Heath refers to as a perturbed. Well, the Greek word there is paragmeni, or in the original Greek elements it says tetaragmeni, which means agitated or perturbed, but really agitated. So if you, for example, if you had to put your hand in a bowl of still water and just wave it around, then the water becomes agitated, and we say the water is agitated, teragmeni. Okay, or teragmeni thalassa, which means an agitated sea. Okay, so in any case, so this is, Heath's translation is totally wrong, because if we're given PQ equal to ST, it's actually not equal, it's in proportion, and QR in proportion to TU, then we have QR in proportion to US. Then to have QR in proportion to US, we must have U squared is equal to ST. And we'll see that in order to have this, this is a particular ratio where this is true, okay? Now, in this ratio here, which is a perturbed or teragmenian analogia, which means perturbed proportion, then it does, U squared is equal to ST does not imply this, which is what Heath thinks, because 1/2 is not proportional to 4 halves, okay? 4 halves is 2, and 1/2 is not 2, it's half. So these are not in proportion anymore. So in other words, it's not a perturbed proportion, it's no proportion at all, okay? The agitated or perturbed characteristic comes in the sense that you should interpret it in this way, okay? You should interpret it in this way. QR in proportion to US, okay? So not in proportion to ST, but in proportion to US. And that, of course, would be the perturbed proportion, because there are ratios formed from magnitudes that are in different positions in each ratio, but still in the same ratio, aequali, okay? So this is one example I've given you here of an actual perturbed proportion. So, QR, which is 1/2 is proportional to SU, and I'll give you these notes in the detail section, but Q and S have different positions. So you can't call that, you cannot call what Heath has described to you here a perturbed proportion, because it's no longer in proportion. You see, it still has to be in proportion. Perturbed means that you can have the situation here, and you can also have QR to US, which are in different positions. Okay, so QR and US are in different positions, right? QR, see, where are the original? QR and US. Okay, so you need to study these things to understand. So that's pretty much it now for the definitions of Book 5. And in the future, I'll start covering the very important propositions of Book 5. And I'll have to tell you that the most important proposition in Book 5 is, of course, Proposition 12, from which all the theory of fractions and arithmetic and everything is laid, so that the transfer can be made to number through the abstract unit in Book 7. So these last two propositions are not that important. Last two definitions here are not that important, but they are used later on, and that's the only reason I covered them. They're used once. So that's pretty much it now. I ask you to become a subscriber if you're not one already, to like my channel, to spread the news of this channel. It's very important that people are able to see and understand the truth, rather than have this narrow-minded, one-sided, flawed understanding that the mainstream academics are constantly pushing on their students, and hence most aspiring young mathematicians end up hating maths, not following STEM careers, etc., because they think they don't have the talent. But there is no such thing as a person who cannot be good at mathematics. Every person is born with the potential to become a good mathematician. Okay, my name is John Gabriel. This is a New Calculus channel. Till next time, goodbye.